Welcome to Key AI Concepts, Machine Learning, Neural Networks, NLP. In this lesson, you'll learn how AI systems learn from data, process human language, and mimic the brain's structure through neural networks. We'll explain the fundamentals, from training models on large datasets to enabling machines to recognize speech or translate text. By the end, you'll see how these core concepts shape the apps we use daily, like recommendation systems, chatbots, and voice assistants. Machine learning, ML, is the science of letting computers learn from data without being explicitly programmed. Instead of following rigid rules, algorithms identify patterns in examples, refining their predictions or decisions over time. For instance, a spam filter learns what spam looks like after scanning countless labeled emails. This adaptive approach makes ML a cornerstone of many AI applications, from image recognition to customer segmentation. Meet Sarah, an avid movie lover. She opens a streaming service, which instantly suggests titles she might enjoy. The service's ML algorithm tracks her viewing history, compares it with millions of other users, and predicts what she'll likely watch next. Over time, the system refines its recommendations, perfectly matching Sarah's evolving tastes. This story reveals how ML-driven engines personalize our digital experiences, sorting through massive content libraries to deliver relevant suggestions. Let's look at a typical ML workflow. Data is collected, cleaned, and labeled, then fed into an algorithm for training. The model's performance is evaluated, often refined, and eventually deployed. This process is standard in most ML projects. Gather data, train a model, test its accuracy, and deploy the solution. Revisit each step as new data emerges, ensuring models stay up to date and effective in changing environments. Spam detection systems rely on ML to filter junk emails. Engineers collect thousands of labeled spam and non-spam messages, training algorithms to spot keywords, suspicious formatting, or malicious links. Over time, the filter learns and adjusts, catching new spam tactics. This real-life example showcases ML's adaptability. No need for manual rule updates. Instead, the algorithm evolves as it encounters fresh data, protecting millions of inboxes daily. Neural networks form the brain of modern AI, loosely inspired by how neurons interconnect in biological brains. They process inputs, like image pixels or audio waves, through layers of artificial neurons, extracting features that lead to final decisions. This architecture underpins much of the deep learning revolution, enabling advanced insights once impossible with traditional methods. Here's a closer look at a simple neural network. It has an input layer, one or more hidden layers, and an output layer. Signals move forward and errors move backward, adjusting weights through backpropagation. By fine-tuning these connections, the network learns intricate patterns. In practical applications, more layers, sometimes hundreds, allow the model to handle complex tasks like facial recognition or natural language understanding with remarkable accuracy. Neural networks excel at image recognition. Think of how your phone groups photos by faces, or how a self-driving car detects pedestrians. These systems often use convolutional neural networks, CNNs, specialized for processing images. By filtering pixels at multiple layers, CNNs identify unique features, like edges or corners, leading to highly accurate classifications. This power extends to everything from medical imaging to automated quality checks in manufacturing. Natural language processing, NLP, teaches machines to understand and generate human language. From chatbots answering questions to apps translating foreign text, NLP algorithms parse grammar, semantics, and context. This field has expanded rapidly, relying on large language models to decode everything from social media posts to academic papers. Whether summarizing text or detecting sentiment, NLP brings a linguistic dimension to AI systems. Ask Siri, Alexa, or Google Assistant about the weather, and NLP goes to work. It recognizes each word, determines the intent, what is the forecast, and retrieves an answer from an API. This same technology powers chatbots for customer support, helping companies handle common queries 24/7. Over time, these assistants personalize their responses, adapting to accents, slang, and individual preferences. Picture traveling abroad with zero knowledge of the local language. You open a translation app powered by NLP to read menus and chat with locals. Despite occasional slip-ups, these models improve over time by analyzing user corrections and vast parallel text data. The result? Real-time translations that bring people closer, bridging language gaps faster than ever before. Take a high-level look at an NLP pipeline. Text is input, split into tokens, analyzed for structure, and finally interpreted for meaning. Depending on the task, this might lead to a translation, a summarized document, or a classified sentiment. By breaking language into smaller components, NLP systems handle complex linguistic nuances, making them indispensable in chatbots, content moderation, and beyond. If you're ready to dive deeper, public datasets on Kaggle or open-source tools like TensorFlow and PyTorch let you experiment. These resources help beginners learn model training, while advanced users can build cutting-edge NLP or image recognition systems. By tapping into community forums and official documentation, you'll gain hands-on experience replicating classic experiments or forging entirely new AI projects. Let's recap. Machine learning allows computers to learn from data rather than hard-coded rules. Neural networks use layered connections to excel at complex tasks like image recognition. NLP helps machines interpret and generate human language, powering translations and voice assistants. Together, they enable applications from personalized recommendations to near-instant translations, ushering in a new era of intelligent, data-driven innovation. Armed with these concepts, you can tackle a host of real-world problems, automating support with chatbots, boosting diagnostics with image-based neural networks, or analyzing social media sentiment. AI skills are in high demand, transforming everything from personalized medicine to self-driving cars. By understanding machine learning, neural networks, and NLP, you'll be well prepared to create impactful solutions in our increasingly data-centric world.